we're going to learn about keyframes, the building blocks of animation. Alright, so far you know how to move an object around and change the time. So let's try setting up an animation. Here we have our character on the left side of the screen at frame 1. Let's move to frame 30 and move that character to the right side of the screen. Now when we play this back, we should see him move from left to right. But what happens is that the character just stays where it is. The computer doesn't remember where he was at frame 1 because we never told the computer to remember that position. To create an animation, the computer needs to mark what changes we've made to our objects, and we can do that by setting a keyframe. Computer animation is nothing more than attributes changing over time. To track those attributes, we have to set a keyframe to tell the computer that we want our object to be here at this time. Think of a keyframe like a box that holds the value of an attribute on that particular frame. You need at least 2 keyframes with different stored values to create an animation, because the computer needs a change in an attribute to animate. To set a keyframe, we can click the key button. So if we move the time back to frame 1 and move the character to -5 on the x-axis, we can set a keyframe. The computer now knows that he is at -5 on frame 1. Now let's change the time over to frame 60, move our character to +5 on the x-axis, and we'll set another keyframe. Now when we play back, we have an animation. The character moves smoothly from -5x to +5x. You'll notice that when we set a keyframe, this little box appears on our time slider. These are keyframes, and we can edit them on the time slider. You can see our current animation takes about 2 seconds. But what if we want to speed it up? Well, we can just select the keyframe on the time slider and drag it to frame 30. Now when we play the animation, it happens in 1 second instead of 2. This way of setting keyframes is okay for a simple animation like this, but when we start to animate dozens of things on our screen, we're going to have to save time wherever we can. Now we can cut out the step of actually clicking the Set Key button by turning on Auto Key. Now what Auto Key does is it sets a key on the current time whenever we change an object's keyable attribute. This can be a double-edged sword because if you don't change the time, you will just be overriding the same key over and over again. But with a little practice, Auto Key can help you animate much more efficiently. Let's quickly recreate our example. So we'll turn on Auto Key and set the first keyframe on frame 1. Now all we do is change the time to frame 60 and move the object. There, we have our animation. In this lesson, we learned about keyframes, the building blocks of animation, and how to use Auto Key to animate faster. In the next lesson, we'll learn about the Dopesheet. In this lesson, we will learn about the Dopesheet. Now from the previous lesson, we know how to set keyframes and move them around in the time slider. Editing keyframes in the time slider is great if you're doing small changes on a simple animation. But let's look at an example of a more complicated animation. Here we have our object falling and hitting the ground. We have a problem when it hits the ground though. It continues moving far too long. Now this is because our rotation keys are not on the right frame. So let's try fixing this using the time slider. First, we'll try to find the correct keyframe, then drag it to the left and play back the animation. Now that change just made the fall happen a little faster, but we still have the same problem. We can't fix this problem using just the time slider. We need another way to edit the keys. We'll use the Dopesheet. The Dopesheet is like a larger time slider that breaks the animation down into easy to see and manage parts. On the bottom are frame numbers, on the left are individual attributes from our object, and on the right are the keyframes. Now each box represents one frame. This gives us precise control of the timing of our animation. To fix the timing, we can just grab the rotation keyframes, shown as the filled-in boxes, and drag them over to the left. Now when we play back the animation, the object drops, moves a little, then comes to a rest. Now this looks good, but let's add some drama to this animation by having it move in slow motion. We can easily do this in the Dopesheet by just grabbing the last group of keyframes and moving them to the right. Now this prolongs the fall. Let's look at the final edited animation. We begin with a dramatic slow fall, then return to normal speed when the object hits the ground. So as we saw, the Dopesheet is a great way to quickly edit the timing of either a large number of keyframes or keyframes of individual attributes. In this lesson, we will learn about the graph editor. So far, we've edited keyframes using the time slider and the Dopesheet. But what's happening between the keyframes? Well, the computer is interpolating between the keyframes, or in other words, filling in the blanks. We can see the result of interpolation when we play an animation because the computer does it automatically. Interpolation isn't visible in the time slider or the Dopesheet, but you can see it in the graph editor. Here we have an animation of an object dropping and hitting the ground. Now there are quite a few keyframes as you can see in the time slider, but let's examine this animation in the graph editor. Now we can see all of the keyframes and their interpolation, but it looks like a gigantic mess. Let's restrict our view to just a single part of the animation, the drop. Without all of these curves, there we go, that's much better. In the graph editor, we have the familiar frame numbers at the bottom, the various attribute names on the left, but what are the numbers in the middle? Well, this group of numbers actually corresponds to the value of the attributes. Now clicking on the attribute's name just shows those keyframes, so let's focus on Translate Y. We can edit a key's timing just by dragging it left or right, but we can also edit its stored value by moving it up and down. Now be careful though, because while you're editing the values, you might accidentally change what frame it's on, or vice versa. Now that we know how to edit keyframes in the graph editor, let's bring back all those curves. These curves, called the function curves or F curves, are a visual representation of the interpolation between the keyframes, and are color-coded just like the axes. They are drawn by the computer based on the value, frame, and interpolation type of each keyframe. Now that we know how the graph editor works, we can learn how to read each F curve. Our object falls straight down, but in the graph editor, it looks like it's moving forward and down. Now, this is a very important thing to understand about the graph editor. The motion of the F curve in the graph editor is not a direct representation of the animation. Instead, it describes how the attribute changes over time. So in the case of our Translate Y F curve, what the graph editor shows us is that our object is moving down in space and forward in time. In this lesson, we will learn how to edit and use tangent handles. So far, we know that keyframes hold values. What about the interpolation between the keyframes? That is controlled by the keyframe's tangents. A tangent is simply a line that defines the direction of the interpolation when it enters and exits a keyframe. We can edit these tangents using their handles to change the motion in between frames. Let's look at an example of a bouncing ball. There is a key in the air at the beginning and at the end of the timeline, and a key on the ground in the middle of the timeline. Okay, let's play it back, and it doesn't look like a bouncing ball. It looks like a ball floating to the ground and then floating back into the air. This is because the interpolation type is set to flat, which makes the motion move at a steady pace. Let's try editing the tangents to fix our animation. First, we'll grab the tangent handle, then drag it up. Let's play back the animation. Well, it's falling faster, but now it moves down too far and the motion is still too smooth. If we grab the other end and try to fix it, nope, that just does the same thing in reverse. To fix this, we have to break the tangents. Breaking the tangents lets us move each handle independently. If we drag the tangent handles into a V shape, our ball now has a sharp transition moving into the keyframe and out of the keyframe. The ball now falls quickly, hits the ground, and then bounces back up into the air. While you might be animating more complicated things, keyframes and tangents make up the backbone of computer animation. Tweaking tangent handles is normally the final step in editing the animation. The following lessons will deal with animating efficiently and ways to create complex animation. In this lesson, we will learn about ghosting and the various interpolation types. Let's take a look at our falling animation. Alright, so far we've seen the animation in the time slider, the Dopesheet, and the graph editor. But none of them give us an easy to see, clear view of our animation. We have to play it, tweak it, and play it again to see if the tweak fixed the problem, and then go back to tweaking. It's not a very fast way to animate. Well, there is one last way to see our animation, and that's with ghosting. When we turn on ghosting, we see that we have a lot more dolls in our scene. Well, these aren't real dolls, but rather glimpses of where the object is in time. Now if we move a keyframe, we get instantaneous visual feedback. Ghosting is very useful for viewing the animation around the current time to see how your changes will affect the animation. Let's now use ghosting to look at the various interpolation types. Here we see our original animation on the left, and the animation with interpolation type set to smooth on the right. You can see that the motion is much more fluid, but it's still too smooth when the object hits the ground. There are no sharp or sudden movements, and this is because smooth tangents conform to the position of adjacent keyframes, which is useful for extremely fluid motions. The next interpolation type we will look at is flat, which just flattens the tangents. If we play back the animation, we can see that our object sort of hangs wherever we have keyframes. This is because flat tangents make the object slow down as it enters and leaves the keyframe. This results in a short pause while it goes through that keyframe. Flat tangents are good for more controlled, smooth animation. Linear interpolation is a very simple interpolation type. It just sets the tangents to create a straight line between keyframes. This type is good for mechanical movements because the animation is steady. It doesn't speed up or slow down. The last common tangent type is stepped. Changing the tangents to stepped really changes the look of our F-curve in the graph editor. When we play back the animation, we can see our object isn't smoothly animated, but instead stays in one place until the next keyframe. This type is good to have as the default type for your keyframes when you begin a very complex animation. This way you can focus on the timing of your animation without the distraction of the interpolation. You will probably need a mix of interpolation types throughout your animation.